Let's just try. Hello everybody, welcome back to the Gregorius Maths video. Today is part what? So okay, we're continuing with the Advent calendar, but the next 2 days of the Advent calendar will be taken up by this topic. So today is sort of a part one, if you will. And what is the topic that I'm talking about? Well, the topic that I'm talking about is the following. That carrying, so when you do like 19 plus 13 and you do 9 plus 3 is 12, so then you have to carry the 1 into the tens column. That carrying, that is an example of a 2 cocycle in group cohomology. And in today's video, I want to be talking about cocycles. And then in tomorrow's video, I want to see how this fits into group cohomology itself. So yeah, today I'm going to be talking about 2 cocycles with the example of carrying. So what we're going to be looking at is we're going to call the group of 1s, so pretty much the integers mod 10, O. It's just 0, 1, up until 9. And we're going to call the group of the 10s T, which is also isomorphic. These 2 groups are both isomorphic to the integers mod 10, but they're going to act in different ways, so we'll distinguish. The 10s are just the 10s, and the 1s are the 1s, so these are our 2 groups. And, well, okay, let's consider addition mod 100. So if we let AI be 10s and BI be 1s, then if we write an element of Z100 as AI BI, so for example 37 is just 3, 7, then in the integers mod 100, A1 B1 plus A2 B2 is given by, well, it's given by A1 plus A2, but then you also have to add some carry function Z of, Z of B1, B2. And then here in the 1s column, you just get B1 plus B2. So notice, crucially, that our addition structure includes this carry function where, for example, where basically, okay, it's defined as you would normally define the carrying. So what I mean is carry of 5, 4 is 0 because 5 plus 4 in the 1s column doesn't require you to carry, but carry of 7, 8 is 1 because you need to carry that 1. So we have to add this carry function in. And notice that the addition structure of, because this is how you add numbers in Z100, in the integers mod 100, notice that it's completely determined by this function Z and these 2 groups T and O. So okay, let's dive into what's happening here. So the carry function is a function Z, and it takes in 2 1s and it outputs a 10. And, well, addition in the integers mod 100 is commutative. So what does it have to satisfy? It has to satisfy that A1 B1 plus A2 B2 plus A3 B3 is equal to, and then we have A1 B1 plus, and then we do A2B2 plus A3B3 first. But if we break this down, what does this really imply? Well, remember this is this, so we get A1 plus A2 plus A3 plus, and then we would have Z of B1, B2 plus Z of B1 plus B2, B3, and then in here we just have B1 plus B2 plus B3 is equal to, what do we get over here? Well, we get A1 plus A2 plus A3 again, but this time we get Z of B2, B3 first, plus Z of B1, B2 plus B3, like so. And B1, B2, I'm just going to dot, dot, dot. And in particular, since these two things have to be equal, this, again, we're working in a commutative group, so there's no issues there, but I don't think there would be anyway. But this and this cancel out. So, and this are the same thing. So in particular, we require Z, if Z wants to define an addition structure using an addition structure built out of these two groups somehow, then it has to satisfy what we call the cocycle condition, and that is that Z of B1, B2 plus Z of B1 plus B2, comma B3 is equal to Z of B2, B3 plus Z of B1, B2 plus B3, like so. So this is the cocycle condition, and we also require some normalization as well for the identity element to be a thing. We require that Z of B0 equals Z of 0B equals 0, like so, for any B in the ones. And these two conditions, this one here is called the cocycle condition, and this one here is called, I think, the normalization condition or something. And recall that these conditions are just coming from the fact that we want to define an addition structure built out of O and T. So in this case, the carrying function Z, well, it does satisfy this, and more precisely, it's defining an addition structure on Z100, but it's not the only cocycle that we can define. For example, we could just take any multiple of this carrying function. For example, if we instead took the function 2z from the ones that takes in two ones and outputs a 10, and all it does is it just doubles the carry function. So every time you need to carry a 1, just carry a 2, basically, is what it does. And how is this? Well, in this case, if we again define addition A1, A2, sorry, A1, B1 plus A2, B2 equals this thing right here, well, then we get a different addition structure. For example, if we did, I don't know, 17, or I should say 17, plus 23, or yeah, 23 will do. Then in this case, in the ones column, you still get 0. But now, normally you would carry a 1, but now we carry 2. So we get 2 plus 1 plus 2 is 5. So we get 50 in this addition structure. So we're defining a different group based on this cocycle here. If you're curious, the group structure that you define is the integers mod 50 direct product with the integers mod 2. Another more trivial example is if you had a cocycle that just does nothing, so it's just 0, it just takes in 2 1s and does nothing. Well, then the addition structure, if you take away this, is precisely just a direct product of the integers mod 10 with itself, because, you know, you just add component-wise. So that's another option. And indeed, if you range through all of the multiples of z from like 1 to 9, you get all of the abelian groups of order 100. And there are only 4 of them, I think. But so you do. So the point I'm trying to make is that this carrying function is actually quite profound, and it's an example of a cocycle, which we can use to build different groups to determine their addition. And so, yeah, okay, that's it for today. That's where I'm going to leave off. So I've motivated what a cocycle is. I've given you this condition, and I've told you that carrying is a 2 cocycle. And in the next video, we're going to look at cocycles a bit more generally and tie this all into cohomology. So hopefully this has whet your appetite for tomorrow's video. And hopefully you enjoyed this video. So yes, indeed, if you have children, if you have little brothers, little sisters, and they've been learning carrying, you can tell them, that right there, that's a cocycle. Boom, there you go. So yeah, stick around for tomorrow, because that's when we're gonna get into the meat and bones of what's really happening. So yeah, but for now, I'll see you then. So enjoy. Bye bye. Yes. Okay.